I'm pleased to introduce the next technical presentation by KAESO. This will be on Revolutionizing Well Integrity with CFLEX by George D. Moraes, General Manager, and Laundry Puna, Operations Director. Please welcome them to the stage.
Good morning, everybody. Thank you for coming. So my name is George Moraes. I'm the General Manager of KAESO. And as already introduced, I'm here with my good friend and colleague, Laundry Puna, Technical and Operational Director. Just before we delve into the presentation, a quick introduction to KAESO. KAESO is a regional content company. We started our operations in Angola. Now we are operating also in Namibia. And our next plans is to start operating in South Africa and in Mozambique. So we are an indigenous company that actually provides services, technical services, directly in the well. So our agenda today will be in 9 points. We'll have introduction on well integrity. We will then focus on cement integrity itself. Then we will see what are the challenges on cement integrity. Then we will touch on the CFLEX technology and the CFLEX applications, followed by its implementation and limitations. Then we will see where the CFLEX was applied in the world. Then we'll review who benefits from CFLEX. And at the end, we'll conclude and see a call for action. So, well integrity. Well integrity is not only about operational efficiency. Well integrity is about safety and financial security as well. As we all know, a single event of well integrity can lead to catastrophic results or consequences. We all remember Macondo and other unacceptable events that happen in our industry. This, of course, can lead to extensive financial losses as well as environmental contaminations. A well failure, in average, can cost 50 million per well. So we're talking about big numbers here. We also know that in the well integrity area, cement problems count for 45% of well integrity failures. So 45% of well integrity failures are due to cement issues. Let's review what is the role of cement. Cement has a key role in our industry. It allows us to have zonal isolation. It prevents fluid migration. And it also gives structural integrity to the well itself. So it prevents the well from collapsing. What are the issues that we can have with cement? We can have poor bonding, that's one of them. We can have also degradation of the cement due to contacts with the fluids. And we can also have problems of shrinkage with cement itself. Now, this will all affect the production, and in some cases, it can also lead to a complete shutdown of the well. So the challenges are many. The production downtime, how does the cement affect the production downtime? 35% of production downtime are due to cement failure. So it is a big problem. and you can have losses up to $1 million per day. The challenges with cement. How can you guarantee a good cement integrity? Well, there are many challenges. One of them is you have some challenges that are mechanical. So poor cement placement is one of them. If you don't have cement in the right zones, you will have problems that will affect your production. You can also have problems that are due to, again, hazardous, I would say environmental, again, chemical degradation of the cement itself. Temperature can affect your cement because it will make your cement shrink. And I would say that the most important problem of all is microannulus, because microannulus can lead the fluids to migrate from the reservoir up to the casing, up to surface, and this will put the well at risk. So how can we prevent all this? I've been talking a lot about annulus. I've been talking about microannulus and also about shrinkage. All this is happening in the annulus section. So imagine now if you had a tool that would allow you to access the annulus, and that will allow you to place the cement exactly where you want to. Well, this tool exists, and this tool can prevent, for example, fluid migrations that can lead to a 25% increase of blowout probabilities. And this tool is called the CFLEX. This tool was designed and manufactured by a company called Archer. Now, let me explain you a little bit how it works. This busy graph that you see on my left-hand side is a graph that represents in the gray, brown, black rock zones the formation. In the white areas, it's the annulus itself. And in the middle, you see this long tubing that goes from top to bottom. That's the casing. In the middle of this casing, you see a tool, and that tool is the CFLEX. So to be clear, the CFLEX is run with the casing. It's an integral part of the casing. And what the CFLEX allows you to do, you see that you have a cement port, and that cement port allows you to get in contact with the annulus. So it is through this port that we can squeeze the cement to place it exactly where we want to. Going a little bit more in details, the CFLEX has three main parts. We have the end coupling, which is the light gray part. We have the housing, which is the dark gray part. And the third main part is the sleeve, which is the yellow part. The sleeve is a movable part. It can go up, and going up, it will close the port, or it can go down, and going down, it will open the port. So we will have access to the annulus itself. You'll see that between the port, we have seals. This is due to make sure that we keep the integrity of the tool and that there will be no leakage. And then you'll see that there is a section called permanent lock in the sleeve itself. This is to give the option to the operator, the client, to permanently lock the CFLEX. Now, I can see that some of you might think that the CFLEX will weaken the casing itself. Well, it's not the case. The CFLEX is built at the same specs of the casing that you are using in your string. So it's not a weak point at all. It will be either the same specs or higher specs. Now, I mentioned that the sleeve can be moved and up, right, to close or open the port. We will do that with a tool that we call the running tool. This running tool has double swap cups at the top and at the bottom. The swap cups are the yellow shapes that you see at the top, at the bottom. And what those swap cups do is then when we push the cement through the middle of the casing, they will make sure that the cement will be directed to the port and therefore going to the annulus. You'll see that in the running tool as well, you have the latching dogs, and the latching dogs will latch into the profile that we saw previously in the sleeve to be able to move the sleeve up and down, right? So you'll see that with this tool, once we have everything in place and we open the sleeve, we can then pump cement through it. Now, this tool has several applications. We can use it above weak zones. We can use it for APB mitigation purposes. But what is important to retain here is that, and we'll go through an example, which is the CFLEX in combination with a tagging system. And what is important to retain here is that if you have an initial problem with your cement job, you can always do a remedial job with the CFLEX to make sure that you keep the integrity of your well. So here you see that we are running the running tool, and we're doing a primary cement job. You see that part of the cement is lost into the formation. Now, to ensure the integrity of the cement in the upper zone, we squeeze the cement through the CFLEX. And now we see that the upper zone below the casing is properly isolated. If we didn't have the CFLEX, we would have to go down through the standard remedial cement jobs. We would have to probably run guns, shoot the casing, and then squeeze the cement through the holes that were done with the guns. So it's a lengthy operation, and it's not always very efficient. You don't know exactly what will be the result of it. Now, how does the cement fits into your operational and financial plan? So this graphic here is a typical, I would say, reservoir cycle. And what you see that if you use the cement, of course, your initial costs will increase by 15%. But what do you gain with that? You will see that you will save on maintenance because you will have less interventions. And by having less interventions, what you will do is that you will also increase the uptime of your production. And in doing so, you are extending your production time. Yeah? So this is all very good, but maybe you're still not convinced that the CFLEX is the right tool for you. So who has been running the CFLEX? The CFLEX has been run by major operators at a worldwide level. You can see that we have operators such as BP, Equinor, Qatargas, and many others. In the world, the CFLEX has been run more than 600 times. More than 600 CFLEXs are installed at a worldwide level. What you can also see is that we have many sizes of CFLEXs. The CFLEXs actually correspond to the sizes of casings that you have at a worldwide level. And these are the sizes that have been run so far. If we look now at the CFLEX in the continent, what have we done with the CFLEX in the continent? We've run 2 CFLEXs in Egypt and Ivory Coast. We've run 8 CFLEXs in Congo. And in Angola, we've done 32 runs. As I said before, KAESO is a company that started in Angola and that is now operating in Namibia. All the other runs that we've been shown to you have been run directly by Archer or their partners. In Angola, KAESO is the one that has run the 32 CFLEXs. So, as you can see, many people trust this technology. What are the benefits? Who can benefit from it? Drilling managers, completion managers will benefit from it because it will reduce the NPT and it will increase the uptime production. You will also see that reservoir managers will be happy with it because it will prevent the undue migration of fluids out of the reservoir. You will also see that well architects will have more flexibility to place the cement exactly where they want, exactly where they need. So you can see that the CFLEX is a tool that will be like an insurance, or there will be the firefighter that is there before the fire arrives. In conclusion, when you look at the global production, you will see that in all the wells that were drilled, only 60% of these wells are operating normally. You will have 20% of these wells that will be operating on dispensation, and you will have 20% of these wells that will be shut in. And most of the times, they are working under dispensation or they are shut in because there is a well integrity problem, most of the times a cement integrity problem. So I'll just let you do some calculations here, taking in account the number of wells that we have in the world, taking in account the oil price that we can average at 70, 60% per barrel, the impact of these wells that are working on dispensation or that are shut in is around $1 billion per day. So it's a big number. So my question to you now is, how can the CFLEX help your operations and prevent these losses? So if you are interested in well integrity and in protecting and in preventing these kind of problems, please contact KAESO and Archer Well. Thank you very much for your attention. If you have any questions, my friend Landry Puna will be ready to answer them. Thank you.
Yes, thank you, George, for this comprehensive technical presentation on the CFLEX. I think now the floor is open for any question. I believe this is quite technical for some of you, but even if you have stupid technical question, you can feed it.
Open? Okay, good. So the thing I wanted to understand more is like how it is different more compared to a regular stage tool. Because it's a stage tool, right? And when you close it, and you use only one usually in one string, or you can use also, let's say, a couple ones in one string, like for deeper wells, or once the, for example, cementing port is permanently plugged, can you reopen that? So these questions is, because these are the things that are making the tool different from the regular stage tools, I guess. So that's the question. Thank you.
Yes, actually, very good question. And I see you understand very well what we're talking about, right?
I slept in the offshore 10 years, man.
So, I mean, this is a revolutionary technology, the CFLEX, right? It has a lot of features, right, than traditional, I would say, collar, right? In particular, the CFLEX, you can actually open and close as you want, right? So the pot, you can open and close it with the cementing tool that you see. And you can actually also permanent close it, right? And I mean, basically when you go to the well with the cementing tool, the cementing tool, you latch in, as George explained, you push down to open, and you pull out to close, right? You can do basically as you want, open and close. But it's important, and some operators like to completely lock it, right? So that in case if in the future you run with a BHA that for some reason latching the profile is very unlikely, you will not be able to open the CFLEX again, right? So we have this CFLEX, right? Also, the big advantage compared to some of the collar cementing, the traditional one, usually you go back and you drill because it has an inner profile that is bigger, than the idea of the casing, right? So you have to go back and drill that one, right? As George explained, the CFLEX is made with the same spec as the casing that you run in the hole, right? You have the same drift ID and close to the same OD, right? Also to preserve the ECD, right? This is what you don't have with the other collar type cementing sleeve, right? And most important, this is qualified as a gas-tight collars, right? So qualify as a V0 for people that knows the meaning, right? So it's quite advanced revolutionary compared to the other stage collar cementing equipment, right? Yeah.
Thank you.
In addition, I think that you had another interesting question. You can install as many as CFLEX you want in your casing, right?
Right, depends on the depth, because we are going deeper and deeper, so.
Exactly. And this also gave you the possibility to do selective zone cementing, right? Depending on where you install your CFLEX. And that's actually happened, right? And even beyond on the cementing, there are other applications. The fact that you can access the annulus can allow you to pump through, right? And we had application in the North Sea where some operators, they have actually installed two CFLEX where they latch in the bottom one and they can circulate through, right, in the inner side, in the annulus through
that's interesting.
the CFLEX, right? And as I mentioned, you open, you close it, or you permanent close it when you want it. Yeah.
Thank you. Now I understand it's a really advanced tool. Yeah, thank you. Have you run it in Turkey? Maybe Archer ran it in Turkey. We are on chemicals, but we can connect to right people maybe. Yeah.
I know you're in the chemical business. That would be a good application or pump whatever type of chemicals, even after your primary stage cementing, right? This can be a good application, right? On that sense.
If I may add something, if you have many CFLEXs installed in the string, you can selectively leave them open or closed. So with the same activation tool, cementing tool, you can go through it without activating it, or else activate it selectively as you want to. And so it gives very much flexibility.
Hi, I would like to thank the first person that spoke for explaining it very clearly. Considering that we're talking about a very high-level investment industry, my question is, what's the life cycle of the CFLEX? Does it have to do with the amount of cement that it processes? I would like to understand a little bit more on that.
If I understood your question properly, you're asking how long the CFLEX lasts. Okay, so the CFLEX will be designed and manufactured at the same specs at your casing. So as long as the casing is there, the CFLEX will be there. Yeah. Welcome.
Yeah, the integrity of the CFLEX will be preserved for the whole life of your well, basically, right?
Hi, congratulate again for the explanation. I'm not a technical expert on that, but was a very good explanation. My question is, in Angola, I saw that you have 32 installed, but the main clients that in the top was like BP. So I wanted to know, what is your market share like in terms of clients in Angola? What is the biggest one?
Yeah, in Angola, the biggest customer for the CFLEX, and they love it, is Total Energy. Right, we start, I think our first CFLEX was installed in 2014, I think I'm not mistaken. And so far we have delivered, I mean, around 32 CFLEX job, right? Yes. Very successful, I mean, jobs. And I mean, from the feedback we have, that's huge saving from the operation side, right? Any other question?
Thank you.
Okay, thank you.